Hey everyone, how's everyone doing today? Doing good? Awesome. All right, well, my name is Ben Reinhardt. I am a junior here at NC State University studying marine science with biological oceanography.
And I'm Ben Register. I'm a senior here studying marine science with also biological oceanography.
And today we have the absolute pleasure of introducing Dr. David Shiffman. He is an interdisciplinary marine conservationist and research associate at Arizona State University. His specialty lies specifically in shark conservation and advocating for its many species through science communication.
Dr. Shiffman engages with the public through his popular Twitter account at Why Sharks Matter, which has over 70,000 subscribers. If you're on shark Twitter at all, it's a really difficult account to miss. I know I see a new tweet every time I open the app. He posts various PSAs, debunks misinformation, and shares his perspective as a scientist with the general public. And although he's based at Arizona State, Dr. Shiffman travels a lot, and he has also served as a guest lecturer at several universities across the country.
Dr. Shiffman we are very fortunate to have a lot of Dr. Shiffman's scientific publications out on the World Wide Web, and this is actually his first book that launched back in May. And a lot of his research is based around conservation, management, and education. And his most recent publication, Why Sharks Matter, delves specifically into the research of the significance of sharks in our ecosystem and in our world.
Thanks everyone for coming today. Thanks Ben and Ben for the lovely introduction. Very excited to be back in the Triangle. I went to Duke for my undergraduate, so as long as we don't talk about basketball, we should get along fine. I'm excited to talk to you today about my new book, Why Sharks Matter. I will note that some folks from the student store do have copies available for sale there. If you want to pick up a copy after the talk, I'm happy to sign and personalize it for you. So, as the Ben's mentioned, I am an interdisciplinary marine conservation biologist. I want to briefly break down what that means, since I know not everyone here is necessarily a marine science major. Marine conservation biology is a little different from regular marine biology that you may have heard of. It means I'm not just interested in where does the sea turtle go or what does this fish eat, but in explicitly using scientific methods to understand questions of conservation importance. Where does the sea turtle go relative to its known threats, and how can we use this to protect them from threats, things like that. And interdisciplinary means I don't just study the fish, I also study the human side. I study the laws, I study the economics, I study the policies, I study what do people know, what do people want, what do people fear, what do people misunderstand about these issues. And all that means that every day is a little bit different, which is awesome. Some days, I'm out on a boat in South Florida, tagging sharks, and doing a variety of food web ecology and migratory behavior studies on sharks. I'm thrilled to say that as a result of this book, we did a fundraiser where 20 of my book readers got to join me for a day of shark research, and we raised $14,000 for some great shark science education charities in doing that. Some days, I'm speaking to policymakers or speaking to the popular press. I do a lot of media interviews. Some days, I'm dressing up like an idiot and speaking in schools. And I've been doing a lot more of that lately, and that's been a lot of fun. In fact, during the first few months of lockdown, when everyone was suddenly doing virtual education, I managed to Zoom into schools in all 50 states. I made 49 on my own. I couldn't get any inroads in Wyoming, and then the Wyoming Department of Education put it out on their social media, and I had to do 12 talks in Wyoming. But still, I got all 50. So I have loved sharks for a really, really long time. I feel like most kids go through a shark thing or a dinosaur thing, right? This is me when I'm 4 years old. This is me when I'm 15 years old. I think I look just about exactly the same in those pictures. The beard is a nice addition. But tonight I want to talk to you a little bit about why I love sharks so much and how they've held my fascination for so long, and some of the things I've learned in a career studying them and a lifetime of being obsessed with them. And in doing so, I want to introduce to you to some of the key themes of the new book. I am happy at the end of this to answer any question that any of you have about sharks or marine biology or ocean conservation or graduate school or careers or my career or the book or anything like that. I just ask that you please hold that to the end of the talk. So I am currently on a book tour, and I'm working a lot with libraries like this one, as well as zoos and aquariums and science museums. I grew up in Pittsburgh, Pennsylvania. We researched it when writing this book. 381.2 miles from the nearest ocean was the house where I grew up. So zoos and aquariums were a big part of the reason why I fell in love with sharks. This is me. That's my younger brother visiting the Pittsburgh Zoo when we were a kid. And the absolute first stop on my book tour was they set up this very same talk that you're seeing here today in front of the shark tank at the Pittsburgh Zoo with the first sharks I ever saw in my whole life. A real full circle moment for me. Don't worry too much about the caution wet floor sign next to the 500,000 gallon shark tank. They assure me it's been leaking for years. They don't know why, but it's probably fine. So one of the reasons why I love sharks so much is they're so weird. It's amazing. They have a lot of incredible behaviors and ecologies and life history traits and biological traits that are so different from anything else out there. And that starts with their skeletons. I want to demonstrate this to you. I want everyone to hold your arm out in front of your face and pick a point about halfway between your wrist and your elbow and try to bend your arm. Hopefully you can't. Now, crinkle your ears, crinkle your nose. You feel how much more flexible that is? That's bone, that's cartilage. Sharks do not have bones. Their skeletons are made out of cartilage. And that's also true of the skates, the rays, and the chimeras, their relatives. Those are known as the cartilaginous fishes. Yes, fishes is a valid term. Other types of fishes, the bony fishes, something like a tuna, a bass, a goldfish, those have bony skeletons. So cartilage is lighter than bone, it's more flexible than bone, it heals faster than bone, but it's not as strong, so there are trade-offs with everything. Another thing that's absolutely amazing about sharks is they have an entire sense that we don't have. I don't just mean they can see better than we can, though they can. I don't just mean they can hear better than we can, though they can. I don't just mean they can smell better than we can, though they can. I mean they can sense an entire set of environmental stimuli that we can't detect at all. They can sense electromagnetic fields. Let me tell you why you might want to do that if you're a predator. If you have a prey item that's hiding under the sand or under the mud, and you can't see it or hear it or smell it, you're going to go hungry that day. But sharks can tell it's there because they can sense the electricity given off by its beating heart. This work was discovered by this work was done by Ad Kalmin, who died a few months ago, and I got to write his obituary and a sort of retrospective of his scientific legacy for American Scientist magazine, which was published in the Research Triangle by Sigma Xi. It's in the May issue. If you guys want to check it out, it's also freely available online, but it was one of the more powerful things I've gotten to write. It was really cool. So we've got some nerds in the audience here, right? I want you to shout out some shark species that you know. Hammerhead, nurse, mako, thresher, basking, lemon, frilled, Greenland, goblin, reef, sand tiger, finally, for the spot a shark team here. All right, that's 10. There are 536 known species of sharks, and with a new species of shark, skate, ray, or chimera discovered somewhere in the world every 2 weeks. It's an incredibly biodiverse group. And they come in a huge variety of shapes, sizes, and colors with corresponding behaviors and ecologies. I want to highlight for you some of my favorite weird and wonderful ones to give you a sense of how biodiverse this group is. So in terms of where they live, there are sharks that live under Arctic ice. There are sharks that live in the deepest parts of the ocean where it's so dark that sunlight never reaches. They live on coral reefs. They live in the middle of the ocean. Just about anywhere you can imagine. In fact, the US Navy SEALs have a saying that if you want to learn if there are sharks in the water near you, you dip your finger in the water and you taste it. And if it's salty, that means you're in the ocean and there are sharks near you. And that's true, but it's incomplete because sharks also live in rivers. So just an incredibly well-adapted group of animals. I want to highlight some of my favorite weirdos here. This, in the lower right, that's the American pocket shark. It is not called that because it's small enough to fit in your pocket, though it is. It's called that because it has this weird pocket of flesh behind its eye that holds glow-in-the-dark liquid that it can squirt out on command to scare away predators. In the lower left, that's a megamouth shark. There's a few reasons why I love the megamouth shark. One is how they were discovered. They were discovered in 1974 when a US naval vessel hit one with their anchor. If they had deployed that anchor chain 30 seconds sooner or 30 seconds later, it would have been years before scientists knew that this species existed. They also have glow-in-the-dark gums. They live in the deep sea where it's so light that sunlight never reaches, and they generate their own light. And that makes prey animals come check out what is that light, and they swim right into their mouths. Snack time goals. They also have the best scientific name in the ocean, possibly on land too, but I haven't checked there as thoroughly. Most scientific names translate to something like the gray bird with the brown spot on its head. This is Megacosma pelagios, the giant mouth of the deep. By scientific standards, that's poetry. And then this guy, that's been an animal I've been identifying more and more with the last couple of years, and I think many of you have as well. You think of sharks as being fast, sleek, powerful, athletic. This is the opposite of that. This is the couch potato of the ocean, the angular rough shark, one of the more ridiculously shaped animals and least hydrodynamic large animals in the ocean, other than maybe the mola mola or some particularly chonky sea turtles. So I love the angular rough sharks. They also have some incredible behaviors. Lots of animals can hyperextend their jaws in front of their face. Snakes famously do this, but nothing does it as far or as fast as a goblin shark. That video is slowed down 100 times so you can see what's happening. That video is not slowed down. That is the cruising speed of the adult Greenland shark, the slowest moving large animal in the ocean. But they're in no particular hurry because they can live to be over 400 years old. They are the longest lived vertebrate animal on Earth. They also eat polar bears, the largest land predator, bigger than lions, bigger than tigers, bigger than all the other bears. Greenland sharks eat them. People ask me, what do hammerheads use that hammerhead for? Hammerheads are a species I work with a lot in South Florida. One of the things is they have extra surface area for that electrosensory system, and you often see them sweeping their head across the sand, much like someone at the beach using a metal detector, basically the same functionality. They also use it to pin flatfish, like a stingray here, against the bottom where they can munch on it. I once saw a hammerhead skull that had 70 stingray barbs embedded in it, so the stingrays are not doing much to protect themselves there. That's a thresher shark. People use, their tails can be as long as the rest of their body combined, and for many years we had no idea what they used that for, until a scuba diver filmed this. They use it as a whip, which makes a shock wave which stuns prey that they can munch on. That's a kite-fin shark, the largest of the shark species whose whole bodies glow in the dark, but there's a whole family of shark species whose whole bodies glow in the dark, and that is the lantern sharks. My favorite lantern shark is the ninja lantern shark, and it is called that because my friend and colleague Vicky, who discovered it right around Thanksgiving. And she was home with her family, and everyone was talking about what's new at work, what's new at school. And she said, I discovered a new species of shark, and I get to name it whatever I want. And her young cousin from the other room says, ninjas are cool, call it the ninja shark. So she did. There are a lot of sharks here in North Carolina. You have all of the big famous ones. You get great whites and tigers here. You also have my favorite shark, the sandbar shark. Follow #BestShark on Twitter and Instagram to learn all about them. And you'll also see years of my scientific colleagues teasing me for choosing what they perceive as a boring shark to be the best shark, but I don't make the rules. I was involved in a really cool study about sharks in the Outer Banks, specifically climate change migration, climate change-induced range shifts of sharks in the Outer Banks. This was actually the first ever documented evidence of a climate change-induced range shift in a large, potentially dangerous predator. And what you see here is scientific data from IMS, the UNC Marine Science Institute. They have a sandbar shark on their beautiful new mural, by the way. I just stayed there last night. They have scientific data from the late 1960s every year of what sharks are found in the bay, or in the Outer Banks in the South. And until about 2005, they never once, not once ever, saw a baby bull shark. It was believed that baby bull sharks could not go farther than North Florida, which is the northern extent of their range. Then about 2005, they started seeing them, this dark red line, and now they see them all the time. What's happened in between the 1960s and 2005? The Outer Banks in the summer are now the temperature that North Florida waters used to be. So there's an addendum to this story. This research got very badly misquoted in some cases. I now live and work in the Washington, D.C. area. We have the Washington, D.C. metro system, our public transit. For those of you who live most of your lives in North Carolina, a public transit system is a way that you can get around a city without driving. So they had all these ads right when I moved to the city about the climate change benefits of taking public transit. Climate change is bad for hops production, save happy hour, take metro, was my favorite one. They also had this. More CO2 will lead to increased shark attacks. Keep the sharks at bay, use Metro. This is an ad that I had to walk by every day going to work that misquoted my own research. And I tried for 6 months to try to get them to take us down. They wouldn't respond to me. This is an article about my campaign in WAMU, DC's NPR station. And they reached out to me to do a story about this. And I said, like, first of all, I just want to say I know that this is silly and doesn't matter. And they're like, yeah, that's fine. And I said, I can either act like this is silly and it doesn't matter, or I can act like this is the most serious problem ever. And they said, definitely do that, play up the seriousness, it'll be great. So we did this very dramatic photo of me staring off into space behind the offending ad. And I'll note that sometime during lockdown, when the metro was closed, they removed all these ads. So I'm still counting it as a win. I finally beat my white whale. So where baby sharks come from is also a really fascinating story in terms of biodiversity. Some sharks give live birth, like this lemon shark. They have no parental care at all. That has to be a miniature shark and take care of itself the second it's born. Some sharks lay eggs. This is actually a skate egg case with the top removed so you can see what's happening here. Some sharks have a weird mix of that's only found in sharks. Some sharks have what's called multiple paternity. A female will mate with multiple males, get pregnant by several of them simultaneously, and give birth to a litter of half-siblings, same mom, different dads, born at the same time. Some sharks can decide that, you know what, now is not really a great time for me to get pregnant, even though we went through all the trouble of mating, and then store the sperm and then become pregnant at a time of her choosing. The record for that is just under 4 years. So there's an incredible diversity of reproductive strategies. So sharks are absolutely amazing. Well, when most people think about sharks, you think about sharks in the context of being a threat to people. And part of this is breathless, hysterical media coverage. My favorite statistic about that is almost 40% of all the reported shark attacks, sarcastic air quotes, reported in Australia. In those cases, the shark did not physically touch the human at all. It swam near them in a way the person reported as threatening. But a big part of the reason why everyone's so afraid of sharks is Jaws. Before Jaws came out, which was this is the 47th anniversary of release this year, a lot of people didn't really think about sharks very much. Fishermen did, surfers did, but people just at the beach didn't really think about it. Jaws changed the world. We actually have something in the public policy literature called the Jaws effect, which is how a fictional portrayal of a real-world issue really influences how people actually think about that issue. And I'll note in what seems like a headline designed to troll me specifically, former UK Prime Minister Boris Johnson said that his political hero was the mayor in Jaws who didn't close the beaches. He said this at the start of the pandemic, so yay. We're totally learning the right lessons about the character who was written to be a ridiculous, over-the-top bad guy. So Jaws so changed the world that the author, Peter Benchley, spent the last part of his life advocating and raising money for shark conservation. He was devastated by how his work of fiction made people want to persecute sharks. And that Ninja Lantern shark that I mentioned earlier, its scientific name is Benchley Eye, to honor that. So people are occasionally injured or even seriously injured or even killed by sharks, but I just want to give you a sense of how rare this is. More people in a typical year are bitten by other people on the New York City subway than are bitten by sharks in the whole world. More people are killed in a typical year by flower pots falling on their head from above than are killed by sharks. As a social media guy, I love this one. More people in a typical year die taking a selfie of the beautiful scenery behind them and falling off a cliff than are killed by sharks. So be careful out there with your selfies. This one's apparently not true anymore, but I now leave it in there out of spite because I got a weird phone call a few weeks ago that you said that more people are killed by vending machines than are killed by sharks. Don't you know that we changed those rules during the Obama administration? There were new OSHA rules about vending machine construction, and now it's not true anymore. And I was so annoyed by this that I now leave it in the talk out of spite. But that did used to be true, that vending machines used to be death traps. They're safer now, thanks Obama. For the record, I don't know anyone who's ever been seriously injured by a shark. I do know 2 people who have been seriously injured by vending machines. So sharks are amazing. Sharks are not a threat to us. And in fact, not only are they not bad, but sharks are actively good. They help keep the food web in balance. And when we're talking about the ocean, that's a food web that billions with a B of humans depend on for food security, and tens of millions depend on for employment and livelihoods. This is a food web. Don't worry if you can't read the words on here, I'll walk you through this. Each box is a fish or a marine mammal or a bird or invertebrate found off Cape Cod, and the arrows are ecological interactions between them. You pull one thread out of that system and it's probably okay. You pull 5 or 10, I start to get a little nervous. You pull 20 or 30, and we're talking about ecosystem collapse. And we do not want this ecosystem to collapse. It's also extra important to keep the top of the food web intact. There's something in ecology called top-down control, that when you remove the top of the food web, things can unravel even faster. This is an example of what's called fear ecology, the ecology of fear. Predators can influence the behavior of prey animals, even if they don't eat them, just by being there or even possibly being there. Prey animals engage in all kinds of behaviors or don't or choose not to engage in certain behaviors because they might run into a predator. If you've ever taken the long way around to get back to your car rather than cut through a dark alley that looked a little sketchy at night, that's fear ecology. You spent more energy, you spent more time, but you felt safer doing it. This diagram, what you're looking at is a seagrass bed. The dark brown on the bottom is a seagrass bed. The individual dots are coral heads, coral bommies, individual units of a coral reef. And the white is sand, where fish from the coral heads have ventured out and eaten the seagrass. You notice they don't go very far. And it makes these beautiful patterns that, this is another example of scientific poetry, that are called, the title of this paper was Halos of Fear Visible from Space. So it's a really neat example of how the presence of predators can have ecosystem-wide interactions, even when they're not actively eating anything. It's worth noting, I surveyed all the environmental nonprofit groups that work on shark issues. This idea that sharks are important, and that's why we should, or sharks are important, and when we lose them, it has negative ecological consequences. By far the most common reason why nonprofit groups say we should protect sharks. So sharks are important, but the bad news is many of them face very, very serious conservation challenges, so much so that this beautiful infographic from 2015, already out of date, it's already worse than this. This says that 1/4 of all known species of sharks and their relatives are considered threatened with extinction. It's now about 1/3, and that's since 2015. The number one threat by far, so much that there is functionally not a number two, is overfishing, unsustainable fishing practice, us, humans killing them. For fins, which you've probably heard of, for shark meat, which you probably have not heard of, even though, as you'll see, it's a bigger and more important and more rapidly growing threat, intentionally, as well as through what's called bycatch, accidentally catching something when you're trying to catch something else. Some of you may have heard of shark fin soup. This is a traditional Asian delicacy. It is sort of the boogeyman of the ocean conservation world, and there's a lot of misrepresentation about it. But over the last 20 years, the consumption of it around the world and trade in these products have dramatically declined. You might think, oh, that's good news for sharks. Well, I just told you that since 2015, things have gotten worse, and that's because we're eating the meat now. The meat market is larger and expanding more rapidly. I will also note that I have had conversations with some ocean conservation activists who tell me that a bowl of shark fin soup, that's evil, that's bad, that's repugnant, that's repulsive. But that grilled mako shark steak, that's fine, that's how normal people eat fish. Other than making no sense from a conservation perspective, either way you've got a dead shark, that's also super racist. There are major issues with this in the conservation community. But you can be forgiven for not having heard of shark meat as a threat. We did an analysis. I had 10 poor undergraduate volunteers who read every newspaper article that had ever been written, or that had been written in the last 10 years about shark conservation, and just counted what was in it. Shark finning and the shark fin trade was mentioned in 6.5 times as many articles as the shark meat trade, even though it is a smaller threat that is declining, where the shark meat trade is a larger threat that's growing. Another important thing that I've learned is that this is bad news, but it is not a lost cause. We know what to do to help. We know how to protect sharks. Scientists know what policies work and when they work and what we need to make them work and when we need your help to work and when some catchy idea doesn't make any sense. An interesting argument with this is how do you think of sharks? And that affects policy preferences. This is a lot of what I do with interdisciplinary conservation biology. Most Westerners would agree that anchovies are a natural resource to be sustainably exploited. Most Westerners would agree that the great whales are wilderness to be preserved. But sharks sort of fall awkwardly in the middle here, with some people feeling very strongly one way or the other, and I'd say it depends on the species of shark. But this makes it a really interesting area for studying public perceptions of this issue. Though I will note that 90% of surveyed scientists, that I surveyed during my PhD, 90% of shark scientists said that the goal of shark conservation should be making shark fisheries more sustainable, not banning all fishing for sharks, not banning all traded shark products. And finally, the last theme of the book, and any of you who follow me on social media see me rant about this one a lot, is that it's great that so many people want to help sharks and help the ocean. It's great that so many people are trying to help, but wanting to help and trying to help are not the same thing as actually helping. And there's a lot of things that people do that are at best useless nonsense and at worst harmful or counterproductive. There are lots of people who are well-intentioned but just don't know any better, and they Google something and they click on the first link and it's not from a reliable source, and then they go down a rabbit hole of nonsense. There are also unscrupulous people who know about this and exploit this phenomenon to say, all of the scientists and the government are lying to you, give me all your money and we'll save all the ocean together. This happens a lot. So this is I want to give you a couple humorous examples of this phenomenon, but there are some troubling ones of wanting to help is not helping. There is a group of people who go around riding sharks, hugging sharks, kissing sharks on the mouth with their face, the part of the shark that has the teeth. They kiss it with their face. And they say, I'm doing science, I'm doing conservation, I'm doing education. I don't know what the hell is happening in that photo, but it is not science, it's not conservation, and it's not education. I'm trying to get this term macho cowboy idiot scuba diver into the peer-reviewed technical literature. I'm optimistic I can make it happen. Worth noting that this is a gender-neutral term. Many of the worst offenders are women. But this is a particular bugaboo of mine. These goofy online petitions. Some of you may have seen change.org or the petitionsite.com. They bill themselves as anyone can change the world, anyone can make a petition. The problem with anyone can make a petition is a lot of people who don't have a clue what they're talking about make petitions, like this one from April of this year, which got 60,000 signatures to ban shark finning in Florida. Not one of those 60,000 people was apparently aware that we banned shark finning in Florida in 1993. This accomplishes nothing. This does not help anyone or anything. All it does is confuse people about what the problems are and what the solutions are to those problems. And it gave change.org 60,000 email addresses, which is why their entire business model. So back to the book here. There are a lot of shark books out there. I have 3 shelves of them at home. Why did I want to write another one? Well, I do a lot of talking to the public, what we in academia world call public science engagement, and what normal people call talking to people. And I find while doing that there are a lot of questions that keep coming up, and a lot of people would say, like, I've never heard of the shark meat trade. I've never heard of sustainable fishing for sharks. Can you recommend something for me to read that explains it that I don't need to have a PhD to understand? And the answer until recently has been, no, not really. A lot of the books about sharks are fun facts about sharks that at the end they say, sharks are in trouble and need your help, don't eat shark fin soup, or don't use plastic straws, or nonsense like that. And I wanted to make an accessible guide. And that was the goal of the book from the beginning. And it's worked very well. I've been blown away by the success so far. I was featured on National Public Radio Science Friday talking about this. I apparently crashed the WNYC internal work Slack channel when I told them about Greenland sharks eating polar bears. Everyone at the radio station went nuts. I was a featured review in the New York Times. I passed Jane Goodall on the Amazon Science bestsellers list. So I wrote this book for me, and I've been thrilled that other people apparently like it too. I'll note again that we do have copies for sale from the NC State Student Bookstore up front, and if you get a copy here, I'm happy to sign and personalize it here for you. I am in the middle of an international book tour. You guys are stop number 28. Thank you so much for having me here today. I will also be giving a longer version of this talk that is more kid-friendly tomorrow night at the Museum of Natural Sciences. And there is a networking happy hour from the Science Communicators of North Carolina group after that, if anyone wants to hear some of this again, but also more. But also, if any of you represent a group that might be interested in a version of this talk or something similar to this in the future, please don't hesitate to reach out. I can do things over Zoom. I can talk to schools. I can talk to other libraries. Never a charge for public schools or public libraries. So before we wrap up and get to questions, I want to thank a few folks here, especially NC State Libraries, especially Karen, as well as Michelle Jewell, who helped set this up and bring me here. I want to thank my family for always supporting this crazy dream of mine. My parents are not scientists. When I said when I was 3 I want to be a marine biologist, they didn't know what that was, but they learned and they supported me the whole time. Now my dad is retired and he brings his golf buddies on shark research trips with me, so I feel like I made it. I want to thank my publisher for giving me a lot of free reign to write a very different kind of shark book, and they've been so supportive the whole way. To give you a sense of what I mean by a different shark book, Johns Hopkins University Press is a 130-year-old academic publisher. I am responsible for an all-publishing editorial team meeting to decide what their house style is for what words you should capitalize in Florida Man. So I've had a lot of fun with this book. I want to thank my friends and colleagues for years of fact-checking and supporting my vision for this. And finally, I want to extend a deep and sincere thanks to you for being here to listen. I can't travel around the world talking about sharks if no one's there to listen. And before I take your questions, I'm happy to answer any question anyone has about any of this, about sharks, about marine biology, about ocean conservation, about careers, about me, about the book, whatever. But first, I want to just tell a quick funny story about this photo. I was a sponsor of the 2019 Sigma Xi conference. Basically a national science fair, and I had this Ask Me Anything You Want About Sharks booth set up. And it was open to the public as well as to the attendees of this meeting, and just all weekend people were coming to ask me questions. It was amazing. At one point I got up to go to the bathroom, and I came back and there was a 10-year-old boy sitting in that seat answering people's questions about sharks. It was great. Thank you so much for coming today. I'm happy to answer any questions that you have. And Karen, cut me off when it's Carol's turn. I have no idea what time it is. Oh, hey, how about that? To give... Oh, we're about to be overtime, Karen. Shark Week is a dumpster fire of nonsense and harmful misinformation. It is a Google me on Shark Week. I'll save time. This is the only thing I ever say Google me for. Google my name in Shark Week, and several media outlets have called me Shark Week's biggest critic. I don't know if that's true, but I certainly despise them with every fiber of my being. That one of my hosts here, who's out of town, Michelle Jewell, who works here at NC State, is on Shark Week from time to time, and her shows are very good. But the median show is not very good, and there is just an enormous amount of ridiculousness. I actually just had another paper, it's in review now, but there's a preprint available online, where we had some poor undergraduates watch all of Shark Week and write down where did it take place, who's the featured expert, what sharks are in it, what science do they do, what was the part of the episode. Man, it is worse than I thought. My favorite statistic that's in it, my field of chondrichthyan science is 62% women. You would never know that from watching Shark Week, and my favorite statistic that we found from the featured experts in the show, among people who have been in more than one episode, there are more white guys named Mike who are not scientists than there are women. And when 62% of the field is women, at a certain point, that's not an accident. Also, 3 of the 4 most common locations that are featured on Shark Week are South Africa, Mexico, and the Bahamas. I don't think I could name 4 people of color who are featured in Shark Week. So it is an enormous platform, and some people like Michelle Jewell have used it very, very effectively, but it is an enormous missed opportunity. What else can I answer for y'all? Anyone have a happier question? Yes, Ben.
So,
Thank you.
sort of how you touched on earlier, a lot of misconceptions from the internet and people's historical information. For people who don't know as much about sharks as a researcher or graduate undergrad may, how would you recommend them going about learning more about that information if they don't I'm not sure?
Yeah, that's a great question. How do we find reliable sources of information and not spread unreliable sources of information? Step 1, if you're not sure if it's true and it doesn't include a source on social media in the year of our Lord 2022, it's probably not true. There are enormous amounts of, a question that I get a lot is like, I just heard this thing on Shark Week last night, is it true? I'm like, I didn't even read what the thing was, it's probably not. I, in fact, scheduled a tweet that got a lot of criticism this past year that popped up at 8:15 on the first night of Shark Week that thing that they just said on Shark Week is wrong, parentheses, I scheduled this tweet 6 months ago. So if you are not sure if something's true, and this is true, I should stress, not just for shark stuff, for everything. If you're not sure if a thing that you saw online is true, and you cannot find any sort of reliable source confirming it, it's probably not. I teach my marine biology students at Arizona State's scientific information literacy. It's a 5-week-long activity that they do where I give them sort of this bullet point of things to look for, and then I give them an obviously reliable article, an obviously unreliable article, have them analyze it, and then they have them go out into the wilderness and find their own articles and analyze it and tell me if it's reliable or not. So basic media literacy is a really useful skill. Social media literacy is a really useful skill. Social media is an incredibly powerful tool for connecting with experts, and there are lots of experts who are on social media. If you follow me on Twitter, I retweet stuff from all my colleagues. I also have a list of all the active shark and ray researchers who talk about their work on Twitter. If anyone in this room who I just met this week is not on that list yet and would like to be, let me know, but I know the Spot a Shark main account is. The Ocean Folks list is people who are in management, science, conservation, education, who are reliable sources. So there are ways of doing this, but step one, I used to see people do this phrasing on Facebook all the time, and it doesn't happen as much anymore. I'm not sure if this is true, but I'm just going to share it. Don't do that. If you're not sure if it's true and you can't easily find confirmation that it's true from a reliable source, it's probably not. Good question. Please. What's my favorite research trip that I've been on? What a great question. I have a lot of fun on just about anything I do. There are very few bad days on the water. I'd much rather be doing that than screaming and cursing at my Excel and R code in the office. But I recently got to have an amazing day in this year. And in Florida, we have species that we call the big three: bull sharks, tiger sharks, and hammerhead sharks, which normally are great hammerheads down there. And typically, if you see one of those, it's been a pretty good day. We got 2 of each, and a bunch of other things, and a shark that we don't know what it was. They probably have they took a genetic sample, so they probably have figured it out by now and just not told me. But that's the first time that that's happened to me in a really long time, especially in Miami, which is a really well-studied area. And we're just right off Miami Beach, and we catch a shark, and we're like, what is that? So it is either the world's skinniest bull shark with some color deformities, the world's fattest Caribbean reef shark that's 500 miles from where it's supposed to be, also with some color deformities, or it's something weird. And yeah, that doesn't happen very often when you study in places like Miami. Great question. Please. Yes, the question is about what would I like to see happen to make the field more accessible for new people. So the most prestigious internship in the world of shark scientists, if you want to volunteer to do that, that will cost you $2,000 a month. There are a lot of people who can't do that, and those people tend to have demographic similarities. This is a major contributor to the lack of diversity in my field, and I would like to see rethinks of the model where you're funding off of just rich kids. There are lots of problems with that. And whenever I bring this up, whenever I bring up unpaid internships, well, unpaid is bad enough, but pay to participate is bananas. Whenever I bring this up, there's always some senior scientist who says, like, I would not be able to do science if I had to pay my staff. And I would say to that, you would not be able to do that science in that way. But other people have. So we also need funders to step up here. There are people who genuinely want to be able to pay their people, but like you can't get grants for that, and I would like there to be grants for that. Just more opportunities is good. The group that I work with in Florida called Field School, getintothefield.com, they have a week-long live on a research vessel experience life as a shark scientist class that's sort of designed for prospective or starting grad students, but anyone can do it. And on every trip, they have one full ride scholarship and sometimes a few partial scholarships too. That was baked into their model from the beginning. Like even if we're just barely breaking even on this, they don't want to be a barrier. That their research vessel is also the only registered research vessel in the United States that has a pride flag and a Black Lives Matter flag on it. So it's that leads to some interesting encounters on the waterways of South Florida, but I'm very happy to support them. We often have boats coming right at us, pointing at the flags, and sometimes it's difficult to tell if they're very happy or very sad. Great question. Thanks. One more question. Okay, great. Please. That is a great question. How do you measure the population of a shark species? So there's a fisheries biologist named John Shepherd who has one of my favorite quotes about my field, and that is, counting fish is like counting trees, except they're invisible and they move. So it's really, really hard to get a population estimate, but what we can do is measure trends. So one of the ways you do that is what's called indices of abundance. This gets mathy very quickly, but let's say you put out 1,000 hooks and you catch 100 great hammerhead sharks, and that's true for 10 years. And then the next year you put out 1,000 hooks and you catch 10 great hammerhead sharks. That means 90% of the great hammerhead sharks are not there anymore. It's slightly more complicated than that, but that's basically the gist of it. So there are also mark recapture studies. The tagging programs are designed for that. You get a sense of, all right, we know that we tagged X number of sharks. We know they're still alive, but only only Y number were recaught. From there, there's formulas to estimate the population. There are also genetic methods for doing this called census size. If you're interested in population genetics, there's a lot of work being done with census size. That is a way that from getting DNA samples of a lot of different animals in the population, there's complex, crazy math that you can do that it tells you this is how many breeding females there are in the population. But the short answer is it's really hard. Great question. Thank you so much. Thanks, everybody. We have another talk coming up here, but I want to note that if after the other talk, if you want to get a copy of my book, I'll be sticking around, and I'm happy to sign and personalize it for you. I see some of you already did that, so I'm not leaving. Just turning it over to Carol here.
Well, thank you so much, Dr. Shiffman, for coming down today and introducing your book and talking a little bit about your work. Next up, we have a very high pleasure of introducing Dr. Carol Price. Dr. Carol Price is a marine conservationist that is currently conducting research at the Center for Marine Science and Technology and is also the conservation biologist for the North Carolina Aquariums. She is currently involved in several conservation projects, including gopher frogs, crystal skipper butterflies, and, of course, sand tiger sharks.
Dr. Price's work on sand tiger sharks is through a program called Spot a Shark USA, and I won't say too much about it right now, but it's a citizen science project that engages a lot of the North Carolina dive community. I will say that both Ben and I worked on Spot a Shark this past summer with Dr. Price. She's an excellent scientist and an excellent mentor, and we are really glad to have her, really excited to see what she has to share.
Thanks for that introduction. I'm here to share with you today how sharks matter for North Carolina State University. And if sharks matter to you and you are a student here and are interested in coming to the coast and perhaps being one of my interns, or just coming to the coast and exploring your own interest in marine science, I want to just share with you a little bit about that program today, kind of around this Spot a Shark project. So big thank you to Dr. Shiffman for letting me share his time today and telling you a little bit about this story. So my main job is as a conservation biologist for the North Carolina Aquariums, but I also teach at CMAS and mentor undergraduates there. So I'm going to talk to you today about one of my favorite sharks. And full disclosure, I am actually have a background in fisheries biology, but this is my first ever shark research project. So it's very exciting, but it's still a learning process for me. And so books like Dr. Shiffman's and papers like him, I read them all the time, and they're wonderful, and he's a fantastic writer, and I think really brings a lot of value because of his ability to translate science for the public. So thank you a bunch. So the shark we're going to talk real briefly about today is the sand tiger shark. It is a native species of shark that you can find not only off of North Carolina, but I'll show you around the world. And they grow to be 6 to 8, 10 feet long. And this is what they look like. So it's a big, beefy, bulky shark with these beautiful speckled patterns on the sides of them, which become important in just a minute. And one of the reasons that I study them is because this is a shark that is very often found in public aquariums, including the North Carolina Aquarium. And so as aquariums become more interested in conservation of the species that they have in their collections for the public to see, they also want to be involved in conserving and protecting and studying those animals in the wild. And so that's how the aquariums got involved in this research project. So sand tiger sharks can be found all over the world, and in some places they are critically endangered for a lot of the reasons that you can learn about in Dr. Shiffman's book, but overfishing and in some cases even extirpation, purposeful extirpation. Fortunately for us, off the North Atlantic coast, we still have a relatively healthy population, although it is listed as a species of concern by NOAA, and you are not allowed to fish for that shark. And so this is where Spotted Shark USA is centered, is off the coast of North Carolina, although it actually started in Australia, and we just sort of borrowed their technology. So why North Carolina? It turns out we have a whole lot of shipwrecks off the coast of North Carolina, and sand tiger sharks love shipwrecks. And so divers come from all over the world just to be able to dive with this shark species. We have harnessed that interest in sharks through citizen science program Spotted Shark USA. So one of the reasons this shark is really good in aquariums is because it plays nicely with other creatures, including human divers. They are very tolerant of human being close to them. You can see a diver can get right up next to them, and that shark is not going to cause a problem if you don't go up and grab, touch, poke, kiss that shark, touch that shark in inappropriate ways. That shark is going to be just fine. And if you can get up right next to it like this diver can and take a picture of that shark, we are interested in that photograph. Remember those beautiful speckle patterns on the side of the shark? Those are how we can identify those sharks. Just like human fingerprints are unique to each individual, the spot patterns on the side of a sand tiger shark are also unique. And we use that from the pictures that divers can send us to make spot maps. And this is what my students, how many students do I have that actually were on my team? Three of my students here, as well as some that I taught here in the crowd. So my students that come in, their core job is to map the spots on the side of a shark, put that into our photo database, and we have computer software that can compare the spot pattern on a new shark to all the other sharks in the library. And what we're looking for is these matching spot patterns like this. It's really pretty rare that you get them, although some lucky students get them on like their second shark that they ever map, and some have to wait and map like 50 sharks before they get one. So, but here's a shark that we saw, a year or so apart on the same wreck. And so we're building this database, and my students that come and help are helping to build this database. And this is what we've kind of learned so far. We have over 2,000 sharks, individual sharks that we have identified at more than 30 shipwrecks. Over 100 of those have been seen on more than one occasion, sometimes on the same shipwreck, just a few days apart, and sometimes it can be many, many days apart. So we have one that's been over 2,000 days, what we call at liberty, so between sightings. And interestingly, about 60% of the sharks that we see are female. And this is important because one of our sort of hypotheses is that North Carolina has a bunch of sand tiger sharks because it's really important for reproduction. We know that they mate here. We know that females gestate off of North Carolina. And we think, but we're still trying to figure out where, they might actually be pupping as well. So still lots of things to learn just about this species. It's often very surprising to people that we don't know very much about this shark. but it's hard to study stuff underwater. It's really hard to get there. They are like invisible trees. So if you are interested in marine science and maybe coming and working with me or with another professor, the program that I will point you to is semester at CMAST. You get to come and live for a semester down at the coast. You take classes with multiple professors, including me, and then you also do a research project. And if you're interested in learning more, you can go on the website. Dr. Eggleston is the director of the Marine Science Lab there, and then Dr. Thayer helps to coordinate our program. And what's really cool about having students come in is that I get to work with like kids who have so many different interests. And so even though their core function is to come and help me do spotted shark stuff and study butterflies and frogs, but different talk, I do have a little shark pack that comes to the coast. And I just want to tell you about each of these students that I've had over the last few years and sort of what their contribution has been. So Michael Mann was my first student in 2018, and he helped just sort of validate spotted shark in general when it first started. Kirsten Bolin, yes, I had a Bolin, the other Bolin sister in my lab, and she really helped me get the project organized and figure out like how to manage data and things like that. Julie Thomas came in and was really interested then in image analysis. So how can you take the photographs that we use and figure out different things about the sharks using some different software. Michaela Beeson I am still mentoring her. It's been like almost 2 years now. But one of the things that she worked really hard on and is still working on is trying to figure out how sharks are oriented around shipwrecks. So I call that like a shark cloud. What does that look like and how do you quantify that? And then she also started up our diver engagement program where she actually goes out to dive shops and interacts directly with divers coming off of the boats. And so that really helps us get more pictures, but also really helps us with community engagement. Then I had Ben Reinhardt come in this spring. And in addition to working on spotted shark, he actually has gotten really interested in shark behavior. So has been going through a lot of videos and trying to hone in on what sharks are doing. Reese Giroux helped to develop some training materials for future students. Ben Register, also here today, did something that nobody else had ever done before, and he was like, I want to develop some stuff for kids. So I connected him with our aquarium educators, and he developed a really nice little education packet. And then finally, I have a student at the vet school who is continuing the work that Julie started on image analysis, trying to figure out if we can learn things about sharks, again, from the pictures that people send in. In addition to NC State students, I also occasionally get to poach from other institutions. So I have some students at IMS that I'm working with, as well as even a student in Florida. So the NC State impact is expanding not just beyond our campuses, or expanding beyond our own campuses. I really want to thank Olympus Dive Center. If any of you get down to the coast, that's the dive shop that we work really closely with. And without them and the divers on their boats, this work would really not be possible. And then, of course, we've got our aquarium dive team, and then the Wild Me, which is the group that has the software that we use. And then finally, I also wanted to highlight another one of my students. This is Era McClanahan. So she used to be an aquarist at the aquarium, but has worked with me on spotted shark for a really long time and is now at Coastal Carolina University. And so she's studying sand tiger sharks at one specific location, Frying Pan Tower, which is this old navigational structure. It's about 30 miles off of Wilmington, and pregnant females hang out there in the winter. They also have a camera there, explore.org camera, where we can get images of these sharks. And so she's building off of her time she still helps me with spotted shark. She's still a technician for that project, but we're also understanding a little bit more about this specific location. So this is the kind of research questions that as students you can be involved in, is not just mapping the sharks, but trying to understand things like which shipwrecks are the most important, and does that change through the year? I kind of know that the answer to that is yes, but trying to figure all of that out is still where we are. And then we're really interested in using this photo identification for to see how individual sharks are using the wrecks and if they show strong sight fidelity. And all of this is just really going to help fill in the story for how important North Carolina and NC State, because y'all are supporting a lot of this research, is. So we're going to continue working on direct diver engagement, trying to integrate spotted shark data with other existing data sets. And then I've got a ton of really cool video data that still needs a lot of analysis. So with that, I'll take any quick questions. There is also, there's a library exhibit in a 360-degree, I have not even seen it yet, that features spotted shark. So I'm going to go see that, and I don't even know where that is, but maybe Karen can help with anybody who wants to go see that. All right. So if anybody has any questions, I'm happy to take those.
Have y'all ever purposely sunk a ship or created an artificial shipwreck to attract sharks?
So I have not, but we have a whole program in our state fisheries, marine fisheries agency. So the Division of Marine Fisheries often purposefully sinks either vessels or reef balls, like big concrete structure or old pieces of bridges or things like that offshore, mostly for fishing, so for recreational fishing opportunities, but sharks tend to really love those. So a lot of the shipwrecks, even the ones that are on our list, some of those were tragic incidents at sea, a lot of them during World War II, but some of them are purposefully sunk just to be able to provide those kind of opportunities. And they turn out to be great places for divers to go, especially divers who want to go see sharks. Yes, ma'am.
Why do you switch from studying
Oh, gosh. Well, I actually started out as a bird biologist when I was in high school. I studied birds for 7 years, and then I was really interested in fish because birds ate a lot of fish. So I studied fish for a while. So I was never really a hardcore fish biologist. I was always really more interested in sort of ecological systems, and especially the networks and the connections between different parts of the ecosystem. So like that very complicated graph that you saw earlier about sort of the community structure, that is really interesting to me. So I just sort of am interested in ecological processes. And so then when I started working for North Carolina Aquarians, we had a couple of pre-existing projects. So the Gopher Frog project that I work on and the shark project were there. So that was how I kind of got involved in those. The butterfly one I found on my own, though. But that's kind of a really, for those of you who are just starting your academic careers, just because you're studying something now doesn't mean that you have to be studying that in 20 years. It's very easy to let the world pigeonhole you and tell you that because you have a degree in fisheries, you should be studying fish. If you have a degree in fish or whatever and want to go study snakes or sea turtles or whatever, if you can find the opportunity, go for it. Because really what you're learning in school is how to think and how to think critically and how to gather information appropriately to answer questions. And a lot of those skills can apply to whatever you're interested in. So, all right. Book signing.